Hey chemistry, happy Monday! There are 3 things I would like you to do today, and 2 of them are from Friday, so you've probably already done at least a few of them. The 2 from Friday are to update your profile photo in Zoom, so when your camera's off, there's still a picture that represents you, whether it's a selfie, a picture of a pet, something about a hobby, anything like that. The second one is to fill out the survey about online learning that I gave you all on Friday. If you missed Zoom on Friday, or need to find the instructions to do either of those things, they are in the PowerPoint that I posted on Friday under the announcement for people who missed the Zoom meeting. Hey, so I got to editing this video and realized that I forgot to say I made and posted a key for the assignment you worked on Thursday. So before you work on the assignment today, please check your answers and be sure you understand how to draw Lewis structures. I will post a link to the key in assignments, and as always, there are files in our files tabs that are keys for the different assignments. We're currently in Unit 2 bonding. The third thing is our new assignment for today, which is looking at different bond types and examples. So let me explain the information you're going to put in these boxes, and I'll do a few examples to help you get started. There were 10 molecules to work on, so the examples I'm using are not the same as molecules off of your assignment. I wanted you to do those 10. So I have 3 different molecules here, but I'm going to go through the same process that you will be going through with the 10 on your page. Let's look at what we've got here. It gives you a website to go to find electronegativity values. It has this box showing electronegativity differences and different types of bonds, and it gives you different molecules. So let's go through the first couple problems. The substance for number 1 of the examples I'm working is oxygen gas, and the formula is O2. It asks you to find the electronegativity difference of the atoms in my bond. So in this case, it's oxygen bonded to oxygen. This link will take you to a periodic table that has electronegativity values for all of the elements. So I am working with oxygen, so I am going over here to oxygen, and I see the electronegativity value is 3.44. So if I go back here, I'm going to show my math. Electronegativity of oxygen is 3.44, and it is bonded to another oxygen, so the second atom has an electronegativity of 3.44 also. If I subtract one value from another, that gives me 0. There are no units. Electronegativity is just a number. So for type of bonds, I'm going to go to my chart here, electronegativity differences, and if it's between 0 and 0.4, the type of bond is nonpolar covalent. Lewis dot model of bond formation. So what they want you to hear is draw the molecular structure. So for O2 gas, it would be oxygen double bonded to another oxygen, and each of the atoms has 4 lone pairs of electrons. I'll insert a picture of that on the screen. The second one here is hydrobromic acid, and the formula is HBr, meaning I have a hydrogen and a bromine that are bonded to each other. So let's find the electronegativity difference from this one. So I need to look at electronegativity for hydrogen and bromine. Hydrogen is 2.2, bromine is 2.96. Always use the bigger value first. Our differences should be positive. So 2.96 minus 2.2. So I'll go back to my chart and type that in. So 2.96 minus 2.2 equals, so when I do that out, my electronegativity difference is 0.76. Okay, so let's go back to my chart. Anything above 0.4 but lower than 1.8 is labeled as polar covalent. So that's what I'm going to label this one. Polar covalent, if I can spell that. And then I'm going to draw the Lewis dot structure. This one is single bonded. Hydrogen has a full duet. It only wants 2 valence electrons with a single bond. And then bromine is surrounded by lone pairs of electrons. So my last example I'm going to work is calcium chloride. So, got to find my electronegativities on the chart. Calcium is 1, chlorine is 3.16. So we're going to use 3.16 first. So 3.16 minus, I forgot calcium already, I think it was 1. Let's check 1.0. So minus 1.0. Alright, so my difference here is going to be 2.16, which puts me over 1.8, meaning this is an ionic bond. And hopefully you saw that because this one is a metal and a nonmetal. So type ionic. And then for Lewis dot model of bond formation, what I would do on this one is show a calcium with 2 valence electrons and chlorines with their 7, and I would show the electrons moving from calcium to the chlorine. So this one you're going to want to use arrows to show that the electrons are not shared. One is being moved to the other. And I'll insert a picture of that also. So you are going to do all 10 of the sample problems you have. And then at the bottom, there are 2 questions. First is give 3 examples of molecules not on the assignment and determine the bond type. So you're going to find 3 more molecules that aren't here and do the same process. Tell me what kind of bond they have. And then the last one asks you, what does polar mean? And it's okay if you don't really understand if you Google it, but take a good first guess. We'll talk about it tomorrow in class. If you have any questions, please come to office hours or send me an email or write them down and bring them to our class meeting on Tuesday. Bye, chemistry. Have a great Monday.